we've really worked to gather a lot of the best in what I call the data engineering meets AI engineering world, who are really setting the precedent for what that looks like. And so as a former data scientist, I'm honored to be here talking about the future of data infrastructure. Please accept my infiltration. But today we'd really like to explore the future of what data engineering looks like in an agentic era, in an era where inference will likely rule, and what that means for the modern data stack. So first, I want to encourage a lot of hot takes from our panelists and really push you to give your spicy ideas. We'll be able to talk more about them, and you can track us down afterwards. And we'll also open it up at the end for a few more questions. So just to start off with, I'm going to introduce myself, and then I'd love to hand it over to our amazing panelists. So first, I come from a data infra background at deep learning at Meta. Did that for a number of years and left to lead data science and AI teams at a variety of startups in e-commerce and in finance. And I really continually found myself very frustrated with the state of dev tools, with the state of data science and data tooling, and got to a point where I decided I wanted to invest in these tools and be able to enable founders and technical leaders who are building actually good tools in the infra and dev tools era that scaled, that really worked with engineering. So I invest at NEA today, primarily in dev tools, data, and AI. And I also lead our internal data science and engineering team, where we're also thinking about a lot of these tools and building our own multi-agent sourcing system. So I'm going to hand it over to my right, Gleb at Datafold, for a quick intro.
Hi, everyone. I'm Gleb. I'm CEO and co-founder of Datafold. In my previous life, I was a data engineer and was lucky enough to be able to build 3 data platforms from scratch, including one at Lyft, where I joined as one of the first data people. I also got unlucky to break data platforms and brought down Lyft's data platform with a 2-line SQL code change overnight. And at Datafold, we're building a platform to automate manual workflows in data engineering. That is, things that historically data engineers would do manually, like testing, data reconciliation across databases, code reviews, data platform code migrations, and we use AI to automate all of that manual work away.
Cool. I'm Nuno. I am a software engineer. I've worked at a bunch of different startups over the years. Currently, I'm a founding engineer at Langchain. I joined as the first employee. I'm creator of LangGraph, which is an orchestration framework for building LLM agents. In a past life, I was also a data engineer once, although not anymore. And and I should say that Langchain is hiring.
Hey guys, this is Diptanu, founder and CEO of Tensorlake. We're building a platform, serverless platform for processing unstructured data. And for people whose unstructured data is in the form of documents, images, text, we have an ingestion API which makes building these workflows even easier. I spent a long time in my career building cluster schedulers at Netflix, at LinkedIn, and at HashiCorp. One of the cluster schedulers that you may have heard is Nomad. I was the creator of that in HashiCorp way back in the day. And then I worked at Facebook for some time, where I was the tech lead of the machine learning platform called FB Learner, and spent some time doing AI infrastructure and research, like in the speech team. I worked on a model called Wave2Vec back in the day in 2019-20, which is a foundation model for speech, and also led the inference engine team at some point there before starting the company.
Amazing. So we've got our experts. We've got a variety of people from backgrounds in engineering, data engineering, and also data science. And we're ready to talk more about the future vision of agentic web paradigm and the agent SaaS worlds, just to lay a foundation. From there, we're going to talk about what this means for agentic data infrastructure. And afterwards, what does that mean for the future of data engineering and the people in this room? So first, I want to start off by talking about agents. Agents are obviously a big topic in 2025, probably in every conversation for today. And there's a huge spectrum of skeptics to believers. How bullish are you on the future of agents, and where are you seeing them work best today? Do you think startups or enterprises have the best opportunity to leverage agents? I'll start off with Nuno.
Cool. I think first it helps to define the word agent. Obviously, I can only give you my definition. Probably every single person on this room might have a slightly different definition. I'll just take them to mean they're applications where an LLM is making some kinds of decisions about how to accomplish a task. So that's very broad, but I think it kind of covers the promise of what agents can be. I think we're at a very interesting time for agents. I'm definitely very bullish on agents. I think we're kind of maybe at a crossroads where agents are interesting for kind of two different reasons. One is you can actually build agents to accomplish some tasks usefully already today. And the other one is if you build an agent, that ends up being probably the best way of generating the data that you need to improve the models on that specific task. So yeah, I think that's pretty interesting. And different verticals, like different applications, will be at different points on that journey, I think. And I think the last thing I would say is I think depending on which of those parts of the journey you're on, startups versus enterprises may have the advantage. So if your task happens to be one where agents with the current models are already kind of good enough, then I think startups actually do have the advantage. Whereas if your task happens to be one where the current crop of models just doesn't cut it, like you need to fine tune the models to make it good enough for people to use, then I think in those cases enterprises might actually have the upper hand because presumably they have the data that a startup doesn't have.
Gleb?
Yeah, I'd say that we've seen quite huge swings in opinions about agents in the data engineering workflow. And we sort of are going from agents will replace data engineers. We'll just all talk to agents in plain text and receive amazing BI analytical insights. And then a bunch of people come out and say like, no, this is all bullshit. And we like swing back and say like, no, agents are all bullshit. It's not going to work. And I think that the truth is, to Nuno's point, there are many applications, many use cases where agents are actually useful today. And many of those applications, specifically in the data engineering workflow, are around not the end state of like, the ask a question to raw data and then get amazing insight, which is backed by rigorous analytics. But if we take the workflow of data engineers, data scientists, and we break it down into what actually people are doing, a lot of these tasks can be outsourced to agents. A lot of these tasks, especially around the kind of DevOps, data ops nature, like testing, code reviews, migrations, are outsourceable to agents because they are very tightly scoped. So the more scoped the task is for an agent, the easier it is to automate today. And once we build those agents and make them work really well, we can A, take away a lot of manual work from people, and B, build towards larger and larger scope progressively, all the way to probably replacing a lot of the end-to-end mundane work of data people.
Maybe I'll build on that too. I think a really good example of where we're starting to see huge opportunities for startups are where there were many opportunities for outsourcing, consulting, services-based work in the past. I think Datafold's a really interesting example of this because it enables this data migration capability. Processes in the past where we maybe would have had to switch, from an Oracle to a Snowflake, a Databricks, in the past would have taken 2-3 years, $2-3 million, depending on your enterprise, and would be a painful and super exhausting process. Now it's pretty possible for agents to play a role in that gap of translating, working with building tests, and really automating a lot of the manual work.
Yeah, I think if people are building agents, people are building a lot of agents out there. I know this because people use our platform for parsing a lot of data and feed them into agents. So I'm not a skeptic. Having said that, it's Silicon Valley had a lot of hype cycles. Not like there was client server in 1999. There were phones in 2008. Cluster schedulers. We did cluster schedulers in 2013. Like Docker happened, and agents are like I think something like that where it's a hype cycle right now. But having said that, the use cases of agents are very real. People are automating a lot of manual work that was done by people with agents at the moment. I think it represents a new way of building software. And I think foundationally, like there is something different about building software using an LLM or putting LLM in the heart of a software than programming a SaaS application in Ruby on Rails. I think agents are pretty close to what we had with SaaS, except like it's a new way of like building automation.
Right.
So yeah, not a skeptic, but I think it's we hear a lot of it because people we are in that cycle right now.
All right, well, maybe not enough skeptics on the panel, but we'll push through. So as we progress towards an agent internet, how do all of you think about a new communication language for agents, such as a model context protocol, MCP from Anthropic, or the agent-to-agent protocol that we've heard about from Google? What role will data play in agent communication in the new infrastructure layer?
I can go first. I think open API was just enough for agents. So I think that was enough. But I also think developers love abstraction, right? Like even though open API was enough and there was ways for agents to use tools or select tools, I think what MCP has done and what Google is trying to do now, I think is helping people because it packages the definitions and the things that we already had today in an accessible way. And when frameworks like LangGraph and other tools like integrate with those things, it makes it really easy for people to like consume those things. So yeah, I think it makes things easy for developers.
Yeah, I would maybe say that for me, MCP, A2A, are, right now, I think they're solutions looking for a problem. I don't think they're necessarily solving the right problem. I think the right problem to solve for LLMs is what do you put in the prompt? Like, how do you manage the context that you send to the LLM every time you call it? And MCP, A2A, they're not solving that. They're just some, transport protocol for how to call the agent. I think that's more or less a solved problem. Like you said, OpenAPI has been around for a while. Much more interesting to me is if we think, even with multimodal LLMs, there's, text is still pretty dominant as the format that LLMs understand. So if we're thinking about a new language for agents, I think that new language is probably how do we translate as many things as possible into text. So things that you don't usually consider text, like tables, which I think is probably very familiar to anyone in this room, or charts. I think that's what's interesting to me about exploring new languages for LLMs. So for tables, I think it's actually, there's some pretty good formats. There's obviously CSV has been around for a while. Markdown tables are great. For charts, things like, for instance, Vega or Vega Lite, I think are really good ways to have an LLM kind of describe a chart as text. And I think there's a lot more stuff to do there. And I think at some point in the future, we will surely move beyond text. And, as as we know, LLMs represent the inputs you send in. They're represented as these, vectors inside the LLM. So as I think, more and more progress will be made in representing different kinds of data in that latent space inside the LLMs. And I don't think we're there yet, but I think that's going to be the next frontier, if you want. For
The MCP demos are cool though.
well, can't argue with that.
We've been building on LLMs for about a year now, with most of our team actually building things on top of LLMs and building features. And I'd say my biggest learning was, so far, not to attach yourself to any particular technology, and try not to make predictions about what is going to be the winning protocol or the winning technology, because the entire field, especially the infrastructure, evolves so amazingly fast that you just can't keep up, and then you start betting on one thing and then another thing starts being more interesting, more powerful. I think the most interesting or powerful thing one can do with, there are so many different protocols and technologies and frameworks, is look for patterns. Like, what are the patterns that a given technology or protocol tries to solve, and try to see if that makes sense for your problem. And if it does, then you can eventually find the right solution for it. So to Nuno's point about the problem versus solution looking for a problem versus other way around. I think looking for the right patterns to solve your problem will lead you to pick the right technology, regardless of what it can do right now.
Yeah, I think we're at a point in the industry today where we're really arguing over what is the lowest level translation layer. And obviously, I think text is really attractive because it gives humans and agents this opportunity to collaborate and to have kind of a shared lingua franca between data, between code, as a latent space with text. And that's really interesting, but does that continue to hold up? Does it maybe improve to move things into Python or even more of a systems level language? I think that's yet to be seen, and maybe another area where we may see spikes of virality in the future. On that point, speaking of virality, everyone here, I'm sure, has tried Cursor. And one of the main topics we've been thinking about a lot in the data engineering space is, why is there no Cursor that is taken off for the data world? I'm curious to hear from our panel, why do you think that is? And do you think that the data field will ever have its Cursor moment like software engineering?
Well, I think one important question to ask is, why have Cursor for data engineers in the first place? Like, what are we looking for to solve? Are we trying to say that Cursor as a tool that combines an IDE and agentic workflows is not sufficient for data engineers? And where do we think such a tool would add the most value? So I think the answer to the first question is probably yes, because data engineering is kind of like software engineering, but there are so many things that are different. It has a state, data is super messy, the inputs and outputs are very messy. And Cursor, tools like Cursor, even though they're great at generating code and they can probably help you write really great, DBT or SQL code, they miss a lot of the things without a data context. I'm not sure that looking for that particular part of the workflow, meaning writing code, is where we could make the most impact right now in the data engineering workflow. Because in my experience as data engineer, you don't spend most time actually writing things. You spend most time around writing code as data engineer, like talking to people, understanding your data, understanding what the right metric should be that you should even build for, testing things, reviewing others' code, and having conversations about, is this the right definition for this metric? And then monitoring your system in production. And I think that the IDE, be that Cursor or not Cursor, doesn't necessarily solve for those things. There may be other tools or combination of tools that actually solve for those operational workflows. So again, back to the question, if we're trying to say we want to maximize velocity of the data team and at the same time ensure, great data quality, however we define it, then optimizing for an ideal IDE might not be where we see the most impact. But in general, I'm all in favor of having a Cursor-esque experience that would be highly aware of the data context. That would be really amazing.
I I think I remember more than 2 years ago, before I joined Langchain, I think at the time text to SQL was a really hot use
Still is.
use case for LLMs.
It's having a second wave, all right?
And it obviously, I don't think has taken off quite as much as Cursor or other coding assistants. And I don't know the answer, but I think it's interesting to think about, like, what was it targeting the wrong user, or was it the wrong form factor, or was it just the wrong time? Like, the models weren't good enough at the time. Obviously, they're much better now. I actually don't know what the answer is, but I think, to your point, if text to SQL eventually is that kind of breakout moment in the data space, I think what that means for the data engineer is actually very much like what you're saying. Like, it's the data engineer's job is probably going to change to be about just making sure that works really well, because they're not the user for that. It's the end consumer of the data that's the user for that.
I think there are several aspects, of Cursor. One is it's super popular. Everybody uses it. Second, it's a breeze to use. They nail down the workflow really well. So there are many things to dissect and unpack here, right? I mean, first of all, I think the data, data is very secure, right? Like, as in, there is a security angle to data. Most developers in a company wouldn't be able to use a tool or pick a tool and send their data to. Like, that doesn't happen. No one is allowed to, like, take a document and send it to, like, a random vendor and be like, yeah, I mean, this is cool, like, give me all the parse data out of it. It doesn't happen in the industry. There is a lot of security, there is a lot of compliance, a lot of, like, red tape that a developer has to go through to choose a tool and use a tool for good reasons. That is one. So I think it's going to be hard for a tool to get that kind of adoption, if they're in the data space, just because of the nature of data. Second, to Nuno's point, query engines, like, which are using LLMs for queries and stuff, there is a cost of getting the answer wrong, usually, in when people are working with data. And so there is this aspect of, can we afford less than 100% accuracy? And the answer is usually no, right? Like, the answer is usually no in, like, a lot of domains. Like, we work with companies in utility, we work with companies in insurance, healthcare. Getting a zero wrong is a big deal in any part of the pipeline. So it takes a lot of time for us to ship a product or, like, test a product, and I think a lot of the things that make Cursor special, like, is going to be tough to do for a data company. Having said that, we have seen tools like dbt, like, get that escape velocity, and they see a lot of adoption. But can it be Cursor? I don't know. It's going to be tough.
Yeah, maybe said simply, to summarize, I think the data world doesn't have as much of an opportunity for a consumer moment.
Yeah.
I think the engineering world, there is a lot of hobbyists. There are a lot of consumer opportunities to pick up new tools, try them, even not bring them into the context of your workflow.
Yeah.
And I think in the data world, the context of the workflow is really everything for accuracy. So it's been very interesting to think about how could the data world better progress. And I think it's going to be slower, but it's going to be really incrementally valuable as we think about the context of our code base and our databases. And that's a great bridge to how we're shifting into the new agentic data infrastructure and thinking about that in the context of the modern data stack. So over the last decade, the modern data stack was built primarily for reporting and analytics use cases. To date, we've seen a separate data stack start to be built for a lot of the new agent workflows and AI applications, particularly focusing on and specializing in inference. So curious to hear, how do you see these two different stacks coexisting? Do you think they'll converge to support both reporting and AI use cases, or will one win?
I think a big unlock of LLMs is the ability to actually make good use of unstructured data. I mean, I'm sure we've all heard this many, many times. But I don't think most of the usual data stack is actually designed for unstructured data. So I think an obvious thing that I'm sure is happening already and will happen more is just having much better support for unstructured data, because that's kind of what you can take advantage of with LLMs. I think that's one thing. Another thing that I think will change is, I think historically a big part of the job of a data engineer was to, create these master tables that are very well defined. They run in some batch job at night, and they update once a day, and everyone then build reports off of those tables, and all that stuff. And I'm sure that's not going away, but with text to SQL as a use case again, I think we will see people querying the raw data more often, like just having these ad hoc queries that are like complex, and they just need to run on demand, and they need to run fast on demand over lots and lots of data. And I think that's going to require pretty different databases, or I'm sure can be the same databases but with pretty different internals.
Yeah, I would extend what he is saying, and I would say unstructured data needs to fit into like existing stacks, right? And for the last 15 years, like since the time Hadoop came out of Yahoo, like putting inference or putting machine learning models in the path of processing data was like not a thing. Spark came out like as like a better version of Hadoop, and it was designed for parsing data which was like semi-structured. And with unstructured data, like inference becomes really important, and that's where LLMs play a role. You don't need to like write custom transformations in a pipeline in the way like you would have to do like 5 or 6 years back. Now LLMs make it like really easy, but the stack for doing it is not great. Like people say on LinkedIn that, oh, Gemini is like amazing at document parsing, try sending like 10,000 documents to Gemini. It wouldn't work just because of the way inference works. And there were solutions for doing things like this in the existing data stack, right? And so similar technology has to be brought in like for building the data infrastructure, which is capable of doing inference on unstructured data. And that integrates into technologies like Delta Lake, Iceberg, and so on. Which then gets to the point where Nuno's agents can do text to SQL. But there is some work there before data from unstructured sources can be queried.
So maybe the modern data stack is the structured data ecosystem, and the new data infra required is really for the unstructured world. And those that will be successful are going to be able to translate between unstructured and structured 100%. In a really easy and let's call it making your databases very liquid. I'll pass it to you. Any other hot takes here? Also, I'll just say modern data stack, we all know has been struggling to scale for a long time. I think that's an understatement here.
I would also add one point here, right? Another thing is like economy, like the cost, right? Existing data stacks were primarily built for processing data on CPUs.
Yes.
Right? Whereas with the new data stack for unstructured data, you need to run a lot of models on GPUs, and the cost of GPUs is not the same everywhere. Right? And existing data systems were not built for like a federated system, right? They were like all like a single cluster in a single deployment, and you throw in jobs at it and so on. The new data stack needs to work across clouds. It needs to be able to consume different type of hardware accelerators for someone to like do this at scale and in an economical way.
Yeah, I guess my data engineering hot take would be that no one would really want to deal with unstructured data if instead they could deal with structured data for the same problem without losing the signal. And I think that unstructured data brought in the modern data stack is there not to replace the structured data or not to replace like our approach to model things and put them into tables or other structured formats, but rather to augment it, right? Things that previously were completely inaccessible for analytics or machine learning or applications now become accessible because we can take completely unstructured things and put them in the ways that are easier to consume. I don't think that means that we're just going to completely throw away, again, all the classic pipelines, because they exist for a reason and they make a lot of things way simpler than if we were just to query like raw documents or raw blobs of JSON or other types. I think it's also clear that there's like increasing blend of these stacks. Previously, the data science stack was completely separate from analytics stack. These days, we see convergence from both ends. I think platforms like Langchain are building more and more integrations with tools that previously would be part of data stack. At the same time, big data platforms like Snowflake and Databricks are having a really cutthroat competition on AI features and trying to really win the hearts and minds of people building AI applications. I think this is great because there's so much we can do leveraging LLMs and Gen AI in general on top of the data that sits there.
Well stated. All right, now we're going to move into the meat of the discussion here, which is really around data retrieval. I'm sure all day today you've heard about retrieval, RAG, all of these different techniques that are used for agentic workflows. And in my opinion, this is really where we get to where data converges with agents. So I'd love to hear all of your opinions on maybe what you're seeing work best across retrieval, both in the short term with techniques similar, including retrieval augmented generation, maybe graph RAG, semantic search, embeddings-based retrieval, maybe to name a more long-term approach, something like a knowledge graph-based infrastructure. Would love to hear what techniques you think are really working, where you'd love to see the industry going for really effective data representation for agents.
I think first on RAG, I think if you were to ask someone a year and a half ago, then I think RAG would be more popular than it is today. But I don't think RAG is ever going to go away. Like, you can have a model with a context window of 100 million tokens, which doesn't, I think that's 10 times larger than the largest one today. And it's still useful to pick what you put in there, because if you have larger models, you can just use larger databases. People love, to store things on cloud storage because it's basically unlimited. So there really is more data there than you can fit in any model of any size. So I think RAG, in the sense of picking what things you will send to the LLM, is always going to be around. What I don't necessarily think will always be around is the distinction that we have today between like semantic search and full text search. And I think in the end, it's all search, and search is, a discipline that's been around for a while, and semantic search or graph search or whatever, they're just different techniques. And I think in the end, there's no such thing as like a winning technique. And if there is, it's really just a mix. I think what I see working really well a lot of the time is hybrid search, which is just simply, you query your semantic search index, you query your regular full text search index, and you re-rank things using a re-ranker model, and that's your results. And that just works better than either one by itself. And I think that's probably, pretty universal and is not going to change.
I would start there. I would start with hybrid search. It's a good starting point to create a baseline. I think it depends on the domain. If you remember, 2 years back there was a RAG survey paper, or maybe a year back, I don't recall, but that had 50 plus algorithms listed in the survey paper, which basically means that there is no silver bullet. It totally depends on the context. So I think establishing a baseline is important. And for that, hybrid search is a good place to be in. Second, what I see working really well is some combination of graphs, some combination of embeddings, and some combination of summarized hierarchies of information, so that during retrieval you can move from between pockets of information really easily. And in domains like healthcare, in domains like insurance, where there is a lot of related things connected with each other, I've seen it work really well. But I think it's important to understand the domain first, for which we are doing retrieval, and then model the indexes, model the information connections in a way which is very tied to the domain.
So I can probably comment on this, but specifically through the lens of data engineering, because I have far less experience in the actual kind of general purpose infrastructure. I think for data engineering, I'm not sure about RAG, but in general, representation of knowledge as graphs and interacting with graphs using AI, I think is the future. To the earlier question about, what would Cursor for data engineers look, I think if we really try to make a breakthrough in data engineering workflow, we would need to use graphs to represent both the semantics of data, like how all the entities in our business interact, right? We use the entity relationship model, which is kind of how things join together, but ultimately it's a graph, right? So we have users and they have transactions and they somehow are linkable, maybe through multiple ways. So most companies don't have a graph representation of their data, but if we do, that enables us or an AI system to understand how things are related, how therefore data can be joined and queries created. And also on the physical level, just as we think about data pipelines, we call them pipelines because they're inherently graphs, right? Data flows from sources to intermediate layer and then to final layer. And so having those two graphs, the semantic graph and then the physical lineage graph, be available to an AI system can be an absolute superpower to automate workflows for data engineering, ranging from the holy grail of text to SQL to more tightly scoped workflows like migrations or data observability and fixing data quality issues. I think graph is just such a fundamental modeling technique to understand the data. I don't think graphs replace Databricks or Snowflake because they're not good at large volumes of metrics and observations, but I think they can represent the knowledge about your data and about your business that can be used by an AI to then interact with your analytical data stores. So I haven't seen it fully cracked yet anywhere, but I think if I were to make a prediction about the future of data engineering, I think the future of data engineering is graph-based.
I love that so much. I could not agree more. As anyone who knows me knows, I have loved knowledge graphs for the last 8-9 years. And it's I think something so fundamental to the data infra industry. We have not ever thought about organizing our data as graphs except in big tech. And the startup ecosystem is just now starting to see the advantages of organizing your data semantically and being able to retrieve information through embeddings as it's needed. So I would echo, I think that's where so much of our infra is going, is giving us this ability to understand the latent space as a multimodal representation of context as we're querying for data. So it won't be two-dimensional anymore. It will be so much more semantically derived. And a knowledge graph representation gives you that. However, the storage component is probably one of the biggest questions right now, and I'd love to hear topics. So if you're working on knowledge graphs, come and chat with me after. All right, let's move into the future of data engineering and take it home here. So the data field is very large, ranging from AI engineers leveraging data for applications to data scientists blending traditional and generative AI, all the way back to less technical data analysts who are working on translating to the business use cases. Which persona do you think will most benefit from AI today, and how do you think that changes the field of data engineering in itself? And maybe to make it a little bit more pointed, what jobs would you take today and which would you not?
I think I'd go back to my earlier point about unstructured data. I think that's the big unlock of LLMs, and I mean, not to say something dumb, but that's more exciting than structured data, which I think continues to be super important. Like, no one wants their, I don't know, ARR number to be computed out of a PDF document or something. That sounds terrible. But I mean, if you can make value of all the unstructured data that you have, I think that's super helpful, and it's just something that wasn't possible before. I think we're still trying to figure out exactly what that means in terms of roles. I think an interesting thing to explore is for unstructured data in particular, there's a lot of stuff you can do about kind of at index time, just create different representations of them. In fact, I would say that is why knowledge graphs are interesting, because with LLMs, you can actually make knowledge graphs finally work. Knowledge graphs have been around, I think, before I was born. But
Neo4j's been going for 19 years, very hard.
But before, you'd actually need, some domain expert or whatever you want to call them, like writing out those knowledge triples by hand, and that made it really hard to actually, use it at scale. But with LLMs, it kind of at indexing time, if you want, you can actually just have the LLM read through all of your unstructured data and extract knowledge triples out of it, and then that's what you index. And I do think a lot of the data engineering role, or some of the data engineering role, not to go too far, will be in spaces like that. The other thing I would add is, as you can see, I'm always going back to the same points. On the text to SQL point, I think that creates a very clear need to see data engineers as kind of the shepherds of good data, or whatever you want to call them, where the role becomes more about ensuring quality. Because if you have an LLM generating these queries and it's a different query every time, maybe, how I think the job of the data engineer maybe becomes partly about making sure that no one accidentally now looks at the number that is slightly wrong because it was an LLM that generated it slightly different this time. I don't know exactly what that looks like in the future. I think a lot of it will be down to writing like verifiers and tests and just like invariants that your data, that all the data that is, all the queries that are produced need to kind of comply with. But I think that's a big open space.
Yeah, I would like to make like 2 points. One is on the infrastructure end, and the other is at the data engineering end. On the infrastructure end, with unstructured data, there is unstructured data everywhere. So what it means is that we are going to be processing a lot more data than we were processing 5 years back. Now, what it means is we need better storage, which is more economical storage, cheaper serving APIs for data. That means object store is going to be really important. And we are going to see a lot of new databases and serving APIs, which are going to move data from object store to SSDs and cache at the time of query. A lot of databases and a lot of serving systems which were built in 2015, 2010, they relied on RAM, like a lot of RAM, a lot of SSDs for storage. Those are going to get really expensive if we want to store all the data that we are processing from unstructured sources. So which I think opens up an opportunity for infrastructure folks to build like a new type of storage engines and serving engines. That is one. And B, on the data engineering side, a lot of things has been said about evaluation of prompts, evaluation of prompts applied to an LLM and so on. Not a lot of people have talked to me about evals of data that is being parsed. The number one thing that I hear, like when I talk to customers in very mission critical domains, is that they want the data to be accurately parsed, accurately extracted, accurately represented in indexes. So I think a lot of the work that data engineers will have to do to make AI applications successful in an enterprise is to validating that the data that is getting stored in the databases is correct in the first place. And what is the accuracy? Like, what is the impact to the business of getting something wrong?
I think I have a slightly more optimistic view than turning data engineers into like data QA people. Not to like, but
I said to my defense, I said it's one of the things that they would have to do.
Ooh, things are heating up.
yeah. I think that if we talk about like how do roles for data practitioners evolve with AI, I don't think roles matter that much. I think what matters right now is your ability as a data practitioner to leverage AI to be, the best in class, whatever you're trying to do. One, like if you're doing data engineering, how can you leverage AI to be faster? Code gen, cursor, AI code reviews, whatever you can do, you can actually ramp up your impact by leveraging existing AI tools. Two, I think maybe even more, exciting is everyone should learn how to build with AI, right? Platforms like Langchain and, turning unstructured data into structured data capabilities give you superpowers. And you should leverage those superpowers to solve whatever problems your organization have right now. I don't think the rules are defined. I don't think the roles are defined. I don't think your original spec for whatever your role was when you joined had building AI apps as part of it. But I think that's what the path to maximum impact is right now, because things that were not possible before are now possible across all the roles. And I think that being able to build AI applications with the modern AI stack is absolutely fundamental skill that I would expect every single role in data to contain.
Yeah. So ultimately, bringing more production capabilities to using data, I think data is going to be much more externally facing in the future, and engineering skill sets will certainly be a huge component of it.